trigonometry has two different laws. One is called the sine law and the other one is called the cosine law. There's no tan law. So let's take a closer look at sine law. You use sine law when you don't have a right angle triangle, kind of like the one in front of us right now. We don't know that that's a right angle triangle. If you did have a right angle triangle, we would just use so, ca, toa. Okay, but when we don't, we're going to use these laws. Now notice that each of the corners is big letters versus its opposite side, which are the side lengths. I'd like to call these two partners. So when you have an angle and its opposite side, you can set up the sine law. That's basically when I have both numbers, the angle and its opposite side, I could set it up with the sign on the top, or I could set it up with the sign on the bottom. As long as when you set up the second set of partners, they're consistent with your first set of partners. Okay, this is very similar to the similar triangles setup. Now let me just show you an example. Okay, so in triangle RST, we have angle S, which is 40, angle T, which is 21 degrees, and little r, which is 46 centimeters. So find little t to the nearest centimeter. The first thing I'm going to do is I'm actually going to draw a diagram, and I'm going to fill in everything I know. So I have my angles down, and I have my little r, which is across from my big R. I'm going to look for partners now. Well, that's kind of weird. I don't see a partner for this one. I also don't have a partner for this one. And there's no partner for this one. So how are we supposed to figure out the sine law? This is a common trick that teachers like to give on tests. You could easily find out the last angle, R, by taking 180 and subtracting the other two angles. So I know that R is 119 degrees. Well, once I have R, I have my partners, big R and little r. And I could immediately set that up into my first fraction. Okay, where it's going to be sine 119 degrees over 46 degrees. And again, if you want to put the sign on the bottom and the little r on top, that's fine, as long as when you set up your other one, it's consistent. Okay, so I'm going to set up t's because, well, that's what I'm looking for. Okay, so big T is going to be 21 degrees and the little t is going to remain unknown. There you go. I'm thinking that you already know what to do next. Cross multiply. Okay. So t is going to multiply the 119, the sine 119, and then your 46 is going to multiply the sine 21. Since t is multiplying sine 119, we want to get rid of it. We want to bring that sine 119 over to the other side, and we're going to divide. Sine 119 over sine 119. And these guys are going to go away. All right. So you see in the next step, we have the division, and we're just going to put that into the calculator. To the nearest centimeter, it'd be 19. And in PowerPoint, it's really difficult to put that approximation dot, so just remember, if you're rounding, you need that approximation dot. Lastly, I have the therefore statement that has the units in there as well. Okay? So what we're going to do now is we're actually going to go over a word problem. There we go. We've gotten to the Spider-Man. Now, I don't remember if this is Spider-Man like the second movie or the third movie. A really bad memory. Getting old, but that's okay. Spider-Man is trying to save Mary Jane from Sandman. So this is the large question. And you know what? I'm just going to draw a diagram to help me out as I go through the question. So let's just picture Spider-Man, Sandman, and Mary Jane. Mary Jane is hiding 53 meters away from Sandman, so I got that. When Spider-Man arrives on the scene, if Mary Jane and Sandman look up at Spider-Man at an angle of 26 degrees and 83 degrees respectively, remember that that respectively means when we mention the first person, that's the first angle, and then when we mention the second person, then that's the second angle. Okay, so how far is Spider-Man from Mary Jane? So I'm hoping you understand this diagram. And just taking a look at it, I don't seem to have any partners again. So that's a problem. We can't set up sine law right away. So again, you know what to do because you've done the first question. Why don't we look for the angle at Spider-Man? So SB is going to be Spider-Man. Let's get rid of all that. Okay, and it's the exact same thing before. I'm just going to take 180 and I'm going to minus those other two angles, and Spider-Man is 71 degrees. Now I have that partnership. Okay, and I've set those up right there. I think I like putting sine on the top. I don't really know why. Then I'm going to set up Sandman because that's what I'm looking for. Okay, what we're going to do is we're going to cross multiply. X is going to multiply with the 71, sine 71, and then 53 is going to multiply with sine 83. And again, to get x by itself, I'm going to divide both sides by sine 71 degrees so that those cancel out. All right, I have to move this over. Let's get rid of all that. There you go. And I'm just going to put it into my calculator, and we get approximately 55.6 meters. Lastly, we put the therefore statement and we're finished. The sine law is actually quite simple, much simpler than cosine law. So good luck with the next tutorial.